Γεια σας και σας ευχαριστώ που μαζί μας. So that was my welcoming you in broken Greek. So I'll switch back to English if you don't mind. Hello and thank you all for joining us. And today we're going to delve into the journey of how Wix created an architecture and a developer platform that greatly enhances scalability, performance, and resilience, all while not compromising on great development velocity for a vast distributed system. So I'm Natan Silnitsky, and I'm a backend infrastructure tech lead at Wix. And for the past 7 years, I've built developer tools and infrastructure tools around the backend, starting with CI/CD with the Bazel build system, going through a lot of Kafka tooling and infrastructure for Wix. And these days, I'm more focused on microservices frameworks. Other than that, I'm a big yoga enthusiast, and I also have spoken in a lot of different tech conferences on subjects of backend infrastructure, and also written a lot of blog posts on this topic. So a few words about Wix. Wix is a powerful website building platform. We were the pioneers of using AI already back in 2016. And with the Wix platform, you can manage your online presence, but also manage your business online. So we have things like from managing the schedule and the bookings of your yoga studio, all the way to sophisticated tools like third-party dropshipping. Our goal is to help any size business, no matter how big or small it is, to use the Wix platform, which means it's become extremely complex over the years with a lot of scaling challenges. So for instance, our system has to deal with around 4 billion daily HTTP business transactions, and around 70 billion Kafka messages that are processed every day. And that is being done now by roughly 4,000 microservices that are written in a hybrid mode with request reply and event-driven architecture. So we will see how we dealt with all the challenges involved in handling this scale. Today we're going to see how, for example, Wix Stores product, as part of the Wix platform, decided to move from event sourcing and CQRS actually to standardized CRUD services in order to better deal with faster development velocity, better scalability, performance, and resilience, while not compromising or getting rid of any features that event sourcing gives us. So I'll explain more later on. So let's start with the Wix stores examples for event sourcing and CQRS. But first, so we have the product catalog service, for example. And here we have the shop owner and the site owner, and they are updating the price of the confetti cannon, because you cannot live without confetti, right? So they update the price on the back end, and then on the front end, you will the visitor for the site will be able to see the updated price for the product catalog. Now, this was achieved until recently with event sourcing and CQRS. So very briefly, what are these things? We have event sourcing where the requests are actually translated into events that happened in the past, and they are appended only, they're immutable. And then CQRS splits between write and read, right? So the read model will actually be a snapshot in time of these events so that read can be fast. So that's a really, really, really quick explanation of event sourcing and CQRS, but we'll get into more details soon. So the catalog write API, we have create product endpoint, and it emits the product created event and persists it into the event store. So, like I mentioned, we have a stream of events that happened. So product 123 was created, and then its price changed, the description changed, and then the stock level changed. And when you want to know what happened to the product and read it and get to the latest state, naively you will play back all of the events, right? And you will get to the latest current state. And what's really nice about this with event sourcing, one of the advantages is the ability to travel back in time. You can actually investigate the production issue and look, wait, why is this product's price set incorrectly? The user complained. Well, you can actually roll back events and get to the event that actually caused it and look at the relevant code and really investigate easily when and how the data corruption happened. But you may be wondering to yourself, if I need to replay all these events when I read on read endpoints, that could be very time-consuming for product catalogs that have a lot of events per product, right? Or if you get a lot of traffic, that can be really slow you down. So what you usually do is you create a snapshot in time. So for Wix stores, they built it on top of Kafka, so they consume the event with Kafka and will build the snapshot in time of product 123. And what's really great about this snapshotting ability is that you can create snapshots that are really tailor-made to specific complex queries that you have. For instance, here the event stream is actually fulfills multiple snapshots. It also fulfills the product snapshot, but also the inventory snapshot. And it can do all kinds of variations and hydrate them all from the same event source. Now, let's talk a bit about the disadvantages. One really straight out of the bat disadvantage is you get a lot more complexity. With CRUD, you just read and write to the database, and that's it. But with event sourcing in CQRS, well, you'll always have to go through this event creation, and you persist them. And then you'll always have some queuing, it could be Kafka, could be Rabbit, or something else, in order to then create the snapshots. You cannot avoid this. It's built in to the pattern. So it will mean that it will be harder to onboard for this kind of architecture by new members of your team. And another disadvantage is when you create these snapshots, you really need to be careful to not get data corruption. And so you're working on top of Kafka, and let's say that the product price changed from 4 to 6, and you need to get it, but for some reason it got delayed, so now you only get the original price of $4. And then you may end up with getting events out of order, right? We have distributed systems where networks and stuff can happen. And then the snapshot may end up with an older, stale description. So in this situation, we end up with a product which is $4 instead of $6 and description A instead of description B. And this snapshot can stay with us for quite a long time sometimes and really reflect bad data. And if you happen to find it out, how do you fix it? Well, a lot of times you will need to start from scratch and replay all of the events for a bunch of products. And it could be like 100,000 products that got some bug in it, right? So reconstructing the snapshot can take quite a long time. And one final disadvantage with event sourcing in CQRS is in the area of reading your own rights. So again, we have an example here of the back office for the store owner, and they request to update the price. They go to the server, right? The request goes to the server. Now, in event sourcing, you need to add an event and then maybe replay new events on top of the snapshot. The response can take quite a long time. So some teams decide to skip getting the response from the server and do optimistic UI and say, okay, I'm quite confident in the result of this change that I did on the browser. But then you may end up when the shopper refreshes the page, the store owner refreshes the page, then you will get the old price because the server actually didn't finish updating yet. So it could be a really bad experience. You cannot have strong consistency with event sourcing. So to summarize disadvantages of this pattern, we get a lot more complexity built in. It's only eventually consistent. You cannot get strong consistency with it. For very massive scales, you really need to make sure that your snapshotting works very efficiently and handle it, and it's very tricky engineering to get it right for extremely high loads. Because you always need to update according to the event stream. Corrupted snapshots can be quite tricky to get right, and read your own writes. Again, you don't have strong consistency, it's another challenge. So Wix stores decided to switch from event sourcing back to CRUD APIs, right? Like the simple, humble CRUD, which is kind of strange, right? Why go back? Actually, this is part of a standardization effort that Wix created to be an open platform that is really easy to develop on it, both for internal developers and external ones. So how will the catalog API look like for stores in CRUD? Well, you have the CRUD acronym, create, read, update, delete endpoints. They're all in the same API, and they update the product document store. And what does this mean, this Wix open platform that I mentioned? Well, basically, if in the past Wix was and still is comprised of small independent startups that move fast, so you get online stores working separately from the restaurant units. So some parts decide to work with CRUD in the past, and some decided to work with event sourcing. These days, we have a single open platform and development platform, and everyone work with CRUD only. And if in the past some of the APIs were driven with test-driven development to get the test to come up with the API design, and a lot of times the front-end developers were really, really influential with how the API would look like, these days the idea is to create a platformized service, which is API first. You need to first think how this API links with all other APIs at Wix, and it needs to serve a purpose not only for your small startup, but for all of Wix and for external developers. So in the past, all these divisions used to create payment solutions again and again and again, but that doesn't make sense. You just need one payment services suite. And also coupons, right? There's no need to redevelop it. So there's need to be one single generic coupons solution at Wix. Now, we have the product catalog API, and even an internal Wix developer of the cart service we want her to call the RPC and get like good extensive documentation and not need to converse with other members of the Wix team because it doesn't scale, right? We have so many services, so many concerns that it just doesn't scale. And of course, for external app developers on top of the Wix platform that, let's say, want to develop a point of sale application, and they will call the product catalog API with HTTP or JavaScript SDK, of course, here it should be well documented and easily understood. And the same for an external Wix site developer. We have a Velo platform for doing all kinds of customizations that we require for your site. So maybe they want to create a custom filter. They don't like the built-in filters, so they can actually call a JavaScript method of the same product catalog API. And we look how, a little later on, how we were able to have all of this unified solution for all of Wix's microservices. Here we can see how Wix stores actually is part of this concept of having a flexible and extensible open platform. So Wix CRUD service actually exposes APIs. So we have the third-party point-of-sale app I mentioned, or site different filtering. So they call API. But Wix CRUD service also defines SPIs. What is SPI? It's basically a plugin where you can change the default behavior of some functionality and allow others to have their own kind of functionality. So, for instance, in tax calculation, you can have third-party developers create their own tax calculation, and Wix CRUD service will use it. And also, we even separate between internal services at Wix. So Wix CRUD service can actually use the product catalog service for getting the product information, but you can also plug in your own kind. So it's highly flexible. And let's not forget about events, right? Events are critical for a more reactive kind of system. So we have events that are propagated to the third-party analytical apps and the site customized code with the JavaScript callbacks, but of course also internally at Wix with Kafka events. So we can see here there's a rich set of tooling built in for each microservice to allow to think about the APIs, the SPIs, and to think about how to make it standardized and platformized. So adding event sourcing complexity on top of that is just, it's too much. And it's pretty much needless here. And let's also not forget, I keep talking about Wix stores, but there are a lot of different vertical solutions that Wix offers: bookings, events, restaurants, etc., but also horizontal services. So we have forms building for the site or joining a loyalty program. It can be for all kinds of vertical businesses needs, so it's horizontal. All of this should be exposed to internal and external developers to use as a platformized service. Now, the building block of this CRUD service at Wix, the engine behind it is Protobuf. Protobuf, those of you who don't use it daily, is an interface definition language that allows you to expressively annotate your API requirements to gain a lot of extra functionality, like validations, permissions, and stuff like that. And of course, gRPC also is defined with the use of Protobuf protocol. So at Wix, of course, Protobuf can be compiled to many different kinds of languages for the scaffolding of the microservice. So at Wix, we do it with Scala and Java, and also JavaScript. And then with the gRPC endpoint, you can easily expose the HTTP REST endpoint. Just annotate and it's done, it's ready. And we also have a lot of automatic tools that consume changes in this Protobuf and update documentation and SDKs for React development and for Velo, our custom site development at Wix. So we have all of this dependent on one single Protobuf file. So here we can see an example. So the product service is a CRUD. You get create, get updated. And I omitted here a lot of different permissions and REST annotations. It's a lot more verbose. And this service works on a single entity. So our microservices are relatively small. And we have a product for the product catalog. And it has, of course, all kinds of fields, right, that you can create, update, patch, and read and query. Of course, here as well, there are a lot of different annotations, validate the sizes, and etc., that I omitted just to have some clarity here as well. Now, like I mentioned, we have infra services that consume changes in this Protobuf and then automatically expose the documentation for HTTP REST for developers, and then also exposes the JavaScript SDKs automatically. So the developer of the single microservice doesn't need to repeat all this work again and again for all the different layers and platform abilities. Okay, so we decided to go back and have simple CRUD, and we kind of lose a lot of the cool stuff that event-driven architecture gives us, right? So actually, we did drop event source architecture, but we fully embraced event-driven architecture, and that is powered by the concept of a domain event. So what is a domain event? Basically, each of these CRUD services has for all of the different endpoints, automatically published domain events. So domain event is description of the change that happens, similarly to the description of the event sourced event. And this happens automatically through the product SDL library. So SDL is what we call simple data layer, and it offers us out-of-the-box fluent language that can easily do the CRUD operations, and it's powered, and it's a document database which is powered by MySQL 8 and with a JSON document. So we don't really need the full relational tables when we work with small microservices, and you also don't get any direct SDL queries because we have these automatic domain events, automatic cleanups, and a lot of propagated solutions to get it all in our platformized world. So the library doesn't allow to do custom work, and if there's a missing feature, then we add it to the SDL library itself. So all you have to do, if you want to make sure that events are published on your endpoints, you add this annotation to have the callback with the event type. Now, we lost the ability with event sourcing to perform this research investigation in production, right? Look at event history, what happened, because with the database, all you see is the mutable latest state. So actually at Wix, what we do is these events are published, domain events are published to Kafka, and then they are consumed by the data analytical team and produced into the data warehouse and the data lake that Wix has. So then developers through a back office can easily fetch and query for all of the related domain events that they care about, and much easier understand what happened and why the data corruption happened. So it's not exactly time travel like possible with event sourcing, but it's pretty close to it. And of course, these domain events are also important for the interactions between services at Wix. So if we want, when we created the eBay bridge service that allows to put any product on a Wix store also on eBay, so it consumes the updates on the products and updates the eBay listing. And not only internal services consume these events, also these Kafka events are automatically translated to HTTP webhooks to get consumed by the different external development platforms that Wix has for HTTP REST exposure and for SDKs for callbacks in React and Velo that I mentioned. All of this is done, again, automatically. You just write the CRUD and the events will propagate to all those who are interested in it. Now, we did this, so we have a new problem that we didn't have in event sourcing, because we need to update the database, but also publish events. So how do we keep data consistency here? What do I mean by, what's the actual problem here? Like with event sourcing, you just persist an event to the event store and you're done. But when you don't have event sourcing, but you still want to have events, you need to have atomicity where you update the database and send the event at the same time, or none of it at all. Why? Because otherwise, the eBay bridge service may lose an update, right? The database will have the product update, but the eBay listing will not. So that's a big problem. So how did we solve it at Wix? So we have quite a unique solution in our case, where we created a resilient producer on top of our Kafka infrastructure, where in case there's some issue where the catalog service for some reason cannot reach Kafka, or there's some technical failure in actually producing to Kafka, then this event will instead be produced to S3. And then there's a separate healer service that continuously monitors for any new items in S3, and then it will produce it to Kafka itself. And not only do we have more resilient producer, we also have a resilient Kafka consumer out of the box, where we make sure that there is a consumer retry policy with the exponential backoff that will make the processing eventually successful. And in case there's some failure that cannot be resolved, it will get to that letter queue and will be handled manually. Now, usually the alternative that is presented in the software industry is to use the outbox pattern or the CDC pattern or both. So with the outbox pattern, you actually have two database tables for each model, where you have the original products table, where you insert or update, and you can actually read from it, so you get a consistency. But you also have the outbox table, where you put, on each update, you put the updated event to be propagated out. And updating these two tables happen in the same transaction. And then you can utilize the CDC, the change data capture, to actually get these events that have changed. And usually with Kafka, you will do it with the Bezium connector, and it will read the low-level event log of the database, MySQL or Postgres, and produce it to Kafka. And then the eBay bridge has a guarantee that the event will be there and the eBay listing will be correct. Now, at Wix, we decided not to go with either of these patterns. Why? Because the outbox pattern means that we need to have a lot more data for each of our data set endpoints. Remember, this is a platformized solution for 4,000 microservices, so this can really put a lot of stress on Wix's databases, all this duplication. And also the same story with CDC, because you get the low-level database change format from the Bezium, and then you'll need to translate it into the higher-level domain event format. So you get a duplicate traffic here with Kafka, which is also a lot more costly. So after analyzing the usage of Resilient Producer, it ended up that our Kafka system is pretty resilient as it is, but with the Resilient Producer, we gain like even a few more nines in quality assurance. So we're pleased with that. Of course, we may change our decision in the future, but currently we think that with the Resilient Producer, it's the most cost-effective solution. Okay, one more thing that we lost when we moved from event sourcing to CRUD is the ability to do data projections easily, right? To do a data model that is highly optimized for a certain query. So for that, we built a tool called Materializer, and we'll see how it is utilized. But let's look first at how we resolve that naively. So let's say that we want to add to catalog service an endpoint called filter product with inventory, right? Okay, so we don't have the inventory information in the catalog service. So first we'll read the information from the product database, and then we'll do an RPC call to the inventory service to get the inventory information. But usually it's more tricky with filtering because sometimes you want to filter by price from the product database and also at the same time with the stock level from the inventory database. So actually, this cannot be done trivially. It's a multi-step process in order to make sure that you get all the exact information you need. You get the list, filtered list from one group, and then you maybe do some in-memory thing to filter from the other group. It's a tricky situation here. Now, pre-microservice architecture, Usually, what will be done here, a database level join, right? It's really straightforward. You join data between two databases and produce the result back, right? But it's really counter to the microservice pattern, right? Because you don't want the microservices to be dependent on one another. You want the data to be encapsulated behind API, so deployments can move fast, changes can be fast between different microservices. And if you allow to have join between databases, you're opening up the possibility to do changes that will break one of the services getting deployed, because you're working on lower level data. So you want to avoid that. But we don't want the complexity and slowness that is involved, slow responses with such more complex queries. So how do we solve it? By employing another library that we call the Materializer, and it allows to have the catalog service to have yet another database table that contains both product and inventory information. And then the Materializer, once it's set up, will consume from Kafka domain events that I mentioned earlier from the inventory service, and consume it and enrich the product information with its relevant inventory information. So without the domain events common schema, the Materializer library couldn't have happened. So the basic building block of domain events is crucial here. Okay, so let's summarize in comparison between the two approaches, because a lot of times event sourcing usually is considered the more optimal approach for complex distributed systems. So in terms of simplicity, I think CRUD definitely wins, especially if you just want to create a simple CRUD and automatically produce domain events behind the scenes. You don't really care about that. They just happen. So you focus on your CRUD, so it's a lot less complexity. In some cases where you do need to support complex queries, where you need to join information from different microservices, then you utilize the Materializer and you get a little bit more complexity. But usually that won't be the case. You don't usually, most of the 4,000 microservices don't need this Materializer. So definitely a much simpler solution, which means that a new team member can easily join and be very productive very quickly and do changes in a much more confident way without thinking about breaking some brittle aspect of our event sourcing pattern. One area where event sourcing will always shine is in write performance, because all you need to do when you write new data is to append another event. So this is a really quick operation. You don't need to lock anything, unlike with the CRUD service that does involve locking. But definitely over on the read performance, you definitely have a big advantage with CRUD. You don't need to worry about replaying events or making sure that the snapshot is up to date with more extra events. You can actually, with CRUD, create a data replication, a table that is continuously replicated, and read from that, and that will be really, really fast. And in terms of consistency, well, actually, event sourcing doesn't really offer strong consistency, right? It's only eventually consistent. Yet with CRUD, you can read from the read-write table, where you can have both read and writes in certain situations where you need to do the read after write. And it will just work. It's very straightforward, unlike the complexity of how to handle reading your own writes in event sourcing. You will maybe need to hop to a different data center, but I don't want to get into multi-data center architecture at the moment. But that may incur a little bit of latency. Now, the two areas that are missing from standard CRUD operation is the ability to have automatic audit log and a time machine capability for production debugging. Well, I hope that I convinced you that we covered that with our automatic domain events that are also propagated automatically to the data warehouse and data lake. And in terms of data projections and answering complex queries, then again, it's really simple, naturally found in event sourcing. So we built another Lego brick in our ecosystem for that specifically, in cases where it is needed. Cool, so to summarize, Wix successfully shifted its vast distributed system entirely to CRUD-based microservices, moving away from the era of maybe CRUD, maybe event sourcing, hybrid. And the transformation was driven by a commitment to standardization based on Protobuf and managed infrastructure with automated code generation from this Protobuf to different languages, to the different platforms, development platforms that Wix offers, and decoupled architecture, because you don't really need to know about the different parts, especially when you consume events. And advanced tools were also implemented to boost the development speed and ensure system resilience and optimize for scale and performance. So the fact that you have a simple data layer means you don't need to write the SQL yourself, but it's not like it's going to put a lot of slowness into your system, because it tries to be really lean and do just what it needed with the JSON document schema of MySQL 8. And with automatic domain events on top of Kafka, resilient producer on top of Kafka, and Materializer on top of Kafka, you get all these tools that allow you to be very flexible in your requirements, but still allow to get resilience, scale, and performance. Cool. So with that, I would open the floor to questions if we have any.
Yes, we have a few minutes if somebody would like to ask something from Natan. Περίμενε. Wait a minute, mister. I will come to you. There you go, sir.
Oh, thank you. Do you rely entirely on Kafka, or do you implement synchronization endpoints also, in case you lose messages, error 500s and such things?
So we don't only use Kafka, but error 500 is in a synchronous request reply, right? So what exactly do you mean?
Yes, let's say the eBay connector that you had. If for some reason it doesn't work, do you have the possibility that eBay can synchronize through a call or something directly with your system? Okay, so like I mentioned, our event-driven architecture has built-in reach-wise exponential backoff. And of course, the handling means you call an eBay endpoint, right? And so in some places at Wix, there is, sometimes a corrective mechanism to do, a job every single day in like really highly critical places to make sure if there's some data discrepancy. But usually you don't need it. Like if, let's say, eBay is down, the specific synchronization service. So put enough exponential backoff and eventually it will recover. So I hope I answered your question. Yes, thank you very much.
Thank you, sir. And we still have 1 minute for one question. Would somebody? Yes? There you go.
Hey?
Yes.
Yeah. Should I ask in Greek or in English? So I wonder, how did you split up to the 4,000 microservices? So what criteria did you use, or workshops, or how did you figure out, that we will split into those services?
The domain modeling.
Yeah, or before you ended up with 4,000, because the number seemed, I don't know the domain at all, but a little big for me. So
yes,
how did you come up with
I get the
4,000?
responses like, you're doing something wrong, 4,000 is too much. But basically, the Wix strategy to beat the competitors is to offer a wide range of business solutions. And it's really a work in progress. Like I mentioned, there were PayPal payments here and there and there and there all around. So having a single payment service and making sure that it's generic and offers everything that is needed. We're actually wanting to migrate not only for single payment for site visitors, but also have a single unified payment system for site visitors and site owners. Yeah, we want to consolidate things. So if in the past it was like move fast and break things, now it's make sure that other developers can move fast on top of our system. But it's not easy to be in API-first mentality and do correct domain modeling. It's really difficult. You need to do sometimes market research. You need to talk to a lot of different elements at Wix, so it's challenging. But there's always V2. You can always do V2 for the API.
Thank you, Natan. We are now starting our short break. Please thank Natan.
Thank you very much.